All right, here we have section 8.2, Pythagorean theorem. So main ideas, use the Pythagorean theorem and use the converse of Pythagorean theorem. So vocab Pythagorean triple. So Pythagorean theorem, its converse. So Pythagorean theorem here. So in a right triangle with right angle at C and hypotenuse of little c, a squared plus b squared is equal to c squared. So if this is a right triangle, that statement is true. So down here, example 1. California's NASA Dryden is located about 117 degrees longitude and 34 degrees latitude. NASA Ames, also in California, is at 122 longitude and 37 latitude. Use the lines of longitude and latitude to find the degree distance between them. So I need to find the difference. So to find the lengths here, so that's distance and longitude. Wait, hold on. It doesn't matter. I just need to find the differences. So this 117 longitude and 122 longitude. So the longitude distance is 5, 122 minus 17. The latitude distance is 34 to 37. So that's 3. So the distance between them, if these are the legs of the right triangle, is 3 squared plus 5 squared is equal to c squared. So 9 plus 25 is equal to c squared. That'd be 34 is equal to c squared, and then take the square root of both sides. So it's going to be c squared of 34 is 5.8 degrees. That's one's degree distance. All right, so example 2 here, you just have a standard triangle, so find x. So same thing, a squared plus b squared equals c squared. You just have to be careful because just because you have two numbers doesn't automatically make them a and b. So in this one, that's a and that's c because c is always the longest side. It's always the hypotenuse. So 7 squared plus, well, I guess we won't use b, we'll use x squared is equal to 14 squared. So 7 squared is 49. I don't know what x squared is. And 14 squared is 196. So subtract the 49 across. 196 minus 49. That's 147. Take the square root. Gives you 12.1. So theorem 8.5 here is the converse. That says that if a squared plus b squared equals c squared, then the triangle is a right triangle. So theorem 8.4 was if it's a right triangle, then a squared plus b squared equals c squared. Remember, converse reverses the order. So that's why if that's true, you get that. So example 4 here, verify this is a right triangle. So there's actually two ways to approach this. You can find the distance of all three sides, and then use the Pythagorean theorem. So we need to find out what QR is, we need to figure out what RP is, and we need to figure out what QP is. So for QR, that's the distance formula in case you forgot. x2 minus x1 squared plus y2 minus y1 squared, all underneath the square root. So for QR, x minus x, so 5 minus negative 3 is going to be 8 squared. Y minus y, 5 minus 6 is negative 1 squared. So that's 64, that's 1, so this is the square root of 65. So for RP, x minus x is 2 squared. Y minus y is 3 squared. So that's 4 and 9, so that's root 13. And then for QP, x minus x is, so 3 minus negative 3 is positive 6 squared, plus y minus y, 2 minus 6 is negative 4 squared, so that's 36 plus 16 is root 52. So this here is my c value, it's the biggest, so I need to check is root 13 squared plus root 52 squared equal to root 65 squared. Now for a problem like this, you don't want to work out these square roots because when you come down here and you square them, they disappear. So the square root of 13 squared is just 13. The square root of 52 squared is just 52, and that's 65. So is 13 plus 52 65? Yes, it is. So the other way to do it would actually be look at the slopes. So for example, from P to R, the slope is 3/2 up 3 over 2. From Q to R, it's -1 over 1, 2, 3, 4, 5, 6, 7, 8. -1/8. And from P to Q, it's 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. -4/6. So if you're going to do it with slope, what you're looking at is you check pairs, and if they multiply to make -1, at least one pair, you have a right triangle. And right here, -4/6 times +3/2 is -12 over 12, which is -1. So the right angle actually sits right there. But if you don't immediately see that, you just check the pairs. -1/8 times -4/6, is that -1? -1/8 times 3/2, is that -1? -4/6 times 3/2, is that -1? If any one of them is, it's a right triangle. So Pythagorean triple is 3 whole numbers, so no decimals, no fractions, that satisfy this equation. So like the most basic one is actually 3, 4, 5, because 3 squared plus 4 squared equals 5 squared. 9 plus 16 is equal to 25. There's also multiples of this also work. So like 6, 8, 10 is also one if you double every value. If you triple it, 9, 12, 15, also one. But a triple is 3 whole numbers that satisfy. Alrighty, last one, determine whether each set of measures can be the size of a right triangle. So that's just check in Pythagoras theorem if it works. So is 8 squared plus 15 squared equal to 16 squared? So 64 plus 225 is equal to 256. I think that's what 16 squared is. Yep. So this is 289. This is 256. That's not true, so no, not a right triangle. So down here, root 3 over 5 squared plus root 6 over 5 squared equals 3 over 5 squared. Now when you square a fraction, you square the top and bottom separately. So on the top, root 3 squared is just 3. The root cancels the squared, and on the bottom you'd have 25. Here, that's going to be 6 over 25. And this is going to be 9 over 25. When you add fractions, you have to have a common denominator. And if that's true, which it is, you can just add the numerators. 3 plus 6 is 9. 9/25 equals 9/25. So yes, the second one is a right triangle. Not a Pythagorean triple, though, because these are not whole numbers. They are fractions. That's the end of this section.